Factor in graph p of x equals 2x cubed minus 6x squared plus x minus 3. In part A, factor algebraically using the integral zero theorem. Rewrite the polynomial. The first step is to use the integral zero theorem to determine potential zeros of the polynomial. The potential zeros of the polynomial are the factors of the constant term. The integral factors of -3 are plus minus 1 and plus minus 3. Determine which potential zeros are actual zeros of the polynomial. The calculations for this step are shown. The only real zero of the polynomial is 3. Now use synthetic division to factor the polynomial. The degree of the polynomial is 3, but we have only one zero. We will need to use synthetic division to continue. Note that a zero of 3 corresponds to a factor of x minus 3. We will divide 2x cubed minus 6x squared plus x minus 3 by x minus 3 to find the remaining factors. Set up the synthetic division. Complete the synthetic division. The quotient is 2x squared plus 1, the divisor is x minus 3, and the remainder is 0. Using p of x equals q of x times d of x plus r, we can write the polynomial in the factored form p of x equals 2x squared plus 1 times x minus 3. In part B, use technology to graph the polynomial. Can the polynomial be factored using just the graph? Use a graphing calculator to obtain the graph of the polynomial. The graph lets us quickly find the x-intercept of 3. While the graph gives us one of the factors, x minus 3, it does not help us find the other factor, 2x squared plus 1. We would still need to use synthetic division to find the other factor. Therefore, this polynomial is not factorable using just the graph. In part C, can p of x be factored any other way? This polynomial can be factored by grouping. Factor 2x squared out of the first two terms. Factor the common expression, x minus 3, out of both terms. This gives us x minus 3 times 2x squared plus 1, the same answer we obtained in part A.